y equals square root x, y equals x minus 2 and the x-axis. Y equals square root x. Not too bad. We know the graph behaves like this. Y equals x minus 2. This is the line. The slope 1, the intercept negative 2. The graph looks like the rising graph, but the intercept at y equals negative 2. The x-axis is the same as the line y equals 0. Okay, we have 3 pieces. So we're going to put them together and find the area of the common region. Do it by hand. Okay, and then the other graph, I use different color. And then the horizontal line. Okay, we get all 3 graphs together. Next, identify the common region. The common region bounded by these 3 graphs is shaded in yellow there. Okay, so we don't care about anything below the green line or the right side of the red line or above the purple curve. Okay, only that region. And then the next, we're gonna identify, when we may have the graph, identify the point of intersection. Definitely we see 0 there. And next, we're gonna identify where these 2 lines meet each other. So the green line is the x-axis or y equals 0, and the red graph here is y equals x minus 2. So what is the x-intercept of this line, or when y equals 0? So we just equate these two graphs or these 2 lines. So x minus 2 equals 0 or x equals 2. So we get the intersection point at x equals 2. And the next one, how about this intersection point? Gonna be the common point of y equals square root x and the line x minus 2. So then what we have to do, we're gonna set up intersection point. Square root x equals x minus 2. It's quite a challenge because you have the square root into the equation. What you would do for this situation, squaring both sides, okay? After you squaring both sides, the left-hand side, you get x squared. Oh, sorry, you get the x. I'm wrong. X, and then the right-hand side, you have the perfect square, which is x minus 2 squared. Just take care of the algebra first. So x squared minus 4x plus 4. We have equation involving the square power or the quadratic equation. Subtract x both sides. Then we get x squared minus 5x plus 4. Next, factor, or you can use a quadratic formula if you feel comfortable that way. So 2 numbers multiply to get positive 4, but the sum is negative 5. That will give us the negative 4 and negative 1. That means we have the solution x equals 4 and x equals 1. Whatever that apply to our problem would be x equals 4. Why I take only x equals 4? Because for x equals 1, it's if you do the if you do the negative side of square root x, you would get the intersection point there, but it's not located in the region that we are working on. So at that point, x equals 4. Okay. From the region that we see, if we do the partition with respect to x, similar to the situation in the past, that you're gonna hit the bound here and then change the lower function into another one, which can be done for this problem. Okay, but it's not convenient. I'm gonna show you 2 different ways. So I'm copying this. So duplicate. So for this problem, I'm gonna clean up the unnecessary stuff and then work on the way that we do with respect to x. Okay. It can be done, but it's kind of more work to do. Again, make it area A, area B. If you do with respect to x, the area equals area A plus area B. Area A from what is the upper function? This one is always upper for both A and B. And for this part, the lower is the line y equals 0. For part B, the lower is the line y equals x minus 2. Okay, two different things. So for area A, can be set up as integral from 0 to 2. The upper function is square root x. Lower function is 0 with respect to x. Area B, the bound starting from the value to the end point, which is x equals 4. The upper square root x, the lower is x minus 2. And don't forget to put parentheses around because there are two terms for the second function. So to clean up, that what you can do by doing with respect to x would be the integral square root x dx plus the integral from 2 to 4 square root x minus x plus 2 with respect to x. So this one is not as bad as the previous example. If you want to do with respect to x, you can keep going from that point, and just what you can do, square root x is the same as x to the power 1/2, and keep going, okay? But now, our goal, like my goal is to let you see as another way to handle this by doing with respect to y. So I'll duplicate this. And this time we're gonna do, oops, wrong one. I'm doing like with respect to y. So let's clean up. Okay. To handle this using with respect to y, you have the entire region. Now you think about the bar. You pretend like you make a bar and make it a crossway like this. And if you move this bar up and down, one function is totally on the right side of the bar and the other function is totally on the left side of the bar. So that means this is a good way to do with respect to y. Okay, with respect to y. If we claim that it's easier to do with respect to y, the width of the bar is delta x or delta y, delta y. That's the width. So for this position or the position for any y, what is the lower y? What is the higher y or the upper limit, lower limit of the y? So that's the next question. We know that the bar gonna be the lowest position at the bottom here, right? The bottom here. So that means the y will be bounded from 0 to the upper part here. And what is the value for the y for the end of the graph? From finding the intersection point, we know x equals 4 is the intersection point. So what is the y value? So the y value, if x equals 4, you can either plug it in the square root x or the x minus 2 function. Okay, for x equals 4, y gonna be square root 4 or 2. That means the upper limit in y is 2. So the bound of the y is from 0 to 2. Okay, now we got the width with respect to y, so it's going to be delta y. The lower limit, upper limit lower limit, and this one is the upper limit. And then the next part, we're going to identify the height of the bar or the length of the bar. For the length of the bar, that is the difference of the right and the left function. What would be the right function? The right function is the one in red, okay? So this one is the right function. And then the left function is the square root x graph. So this one is the left function. I'm going to write the notes here. So the left function is y equals square root x. But recall, we do with respect to y. We're going to have to solve for x to write x in terms of y. So that means x equals y squared. So that's your left function. And next, what is my right function? My right function is originally in the form of y equals x minus 2. Therefore, my right function will be in terms of x as x equals y plus 2. Okay? These are the prep information. We have the width, we have the lower limit, upper limit, we have the right function, we have the left function. The next, the area of this region going to be the definite integral from the lower limits to upper limit, lower limit 0, upper limit 2, sorry. And the right function minus the left function multiplied by the width, which is with respect to y. In our case, the right function is y plus 2. The left function is y squared. And do it with respect to y. So this is a setup when you use the with respect to y for this problem. The next part, you just find the antiderivative. So y squared over 2 plus 2y minus y to the third over 3. And then lower limit 0, upper limit 2. Work on the problem to get the answer as 10 over 3.